In this example, we're asked to basically solve the triangle again. So we're going to look for all the angles that we haven't solved for yet, as well as the sides. So this is the information that's been given to us. You don't need to have a triangle drawn out, but if it helps you understand the information that's been given to you, feel free to do that. So I'm just going to go ahead and draw an oblique triangle. This is not even going to be drawn accurately. All right, I'm just going to call this one A, B, and C. You can really do it in any order. All right, but I know that angle A is 25 degrees. All right, side B, which is across angle B, is going to be 9 meters. All right, and side C, which is across angle C, is 12 meters. All right, so let's go ahead and take a look at the information that we have. So if you notice, this is an SAS triangle, right? I have an included angle, the angle that is between two sides that are adjacent. So I can use law of cosines. Let's go ahead, because I have angle A, the only thing we can find right now using law of cosines is side A. So I'm going to use the formula to find side A, which is this one right here. Alright, so I'm going to go ahead and write that down. So we have A squared, right? So side A is going to be equal to B squared. So B squared is 9, that's 9 squared, plus C is 12, and that's squared, minus 2 times B, but not squared, just regular B, times C, and then cosine of angle A, which is 25 degrees. All right, so let's go ahead and plug that into the calculator and see what we get. All right, so I have 9 squared plus 12 squared minus 2 times 9 times 12, and I'm going to multiply all that by cosine of 25. Make sure that you are still in degree mode and not radian mode. Alright, so we end up getting A squared is equal to 29.2375 and so on. So that gives me side A but squared. So we're going to go ahead and square root that. So second square root, and I'm going to go ahead and copy that value. We know that when we square root, you get plus or minus, but it wouldn't make sense to have a negative value for a side length. So we're only going to consider the positive value. So we're going to say that side A is approximately 5.4 meters. Excuse me. All right, so side A is about 5.4 meters. Okay, next let's go ahead and find either angle C or angle B. I'm just going to go ahead and find angle B. So let's see what that gives us. Now at this point, we actually do have a complete set of information. We could use law of sines, or you can just continue using law of cosines. Law of cosines is always going to give you the one and only answer for that angle. So I'm actually intentionally going to use law of sines to show you how to decipher when you have two possible answers, because we saw that in the last unit. So let's go ahead and use law of sines. So I am looking for angle B, so I'm going to do sine of B all over side B, which is 9. I'm going to set that equal to the A's. So sine of A, which is 25 degrees, all over approximately 5.4. So I'm going to multiply by 9 on both sides. Sine of B, and that will give me sine of 25 degrees over 5.4 times 9. So let's go ahead and see what we get in the calculator. All right. So I have sine of 25 divided by, we could use 5.4 this time. I'm going to go ahead and just copy that value. And then I'm going to multiply that by 9. So we have that sine of B is equal to 0.7034, and so on. All right, so that's what we have so far. Remember that when we are solving for an unknown angle, we're going to use the inverses. So I'm going to do sine inverse of the left side and sine inverse of the right side. All right, so I'm going to end up with B is equal to, and we're going to see what that value gives us. But I want you to consider one thing real quick. Remember that sine has a positive value, so this number is positive, not negative. Sine has a positive value in quadrants 1 and quadrant 2. And so when we do sine inverse, it's going to be possible that we have an angle either in quadrant 1 or in quadrant 2. We're going to have to figure out which one that is. So let's go ahead and do sine inverse, and let's see what we get. So I'm going to do second sine inverse of this entire value. All right, and we get B is 44.7027, and so on. All right, now again, let's consider something. That could be this angle that has a reference angle of 44.7 and so on, or it could be this angle, which we would have to do 180 minus that reference angle. All right, so let's see what that equals. So there are two possible choices for B. So let's do 180 degrees minus this angle to see what the second quadrant angle would be. All right. So here's the scenario. We have two possibilities for angle B. All right, now let's take a look. If we had 135 degrees as my angle B, that means that angle C would have to be larger than 135 degrees. Why? Well, because angle C is opposite of the longest side of the triangle, right? So would it make sense for angle B to have an angle larger than angle C? Because angle B's side is smaller, right? So side C and angle C correspond. Side C has to be the largest angle, so it's not possible for this angle, for angle B and angle C to both be obtuse. That wouldn't make sense. There's only 180 degrees in a triangle. So it's not possible for angle B to be obtuse, so I can disregard this answer, and I know that angle B has to be 44.7 degrees approximately. Okay, and then at this point, I can go ahead and do 180 degrees minus 25 minus 44.7. All right, and then let's go ahead and see what that gives us. So 180 minus 25 minus 44.7. So that's going to give us 110 degrees, or 110.3 degrees for angle C. Alright, so we have completely solved the triangle with all its missing sides and angles.